Hi there, my name is Andy Smerdon from Aquatec, and I'm going to talk today about smart cable and CPS monitoring solutions, taking the guesswork out of cable system performance. So a quick overview, I'm going to talk about in situ cable monitoring, through water communications, how we get the data back to you, the user, and integrated cable and CPS monitoring solutions. So Aquatec is an award-winning company. We design and manufacture subsea solutions for monitoring the structural health of your underwater assets. So within subsea integrity, we're taking measurements, we communicate data, interpret that data, and sometimes apply control. And we're also active in ocean science in both suspended sediment and marine bioacoustics. This is a quick overview of the areas that we cover. So back to cable protection systems. The challenge is cable protection system failure and cable failure. So subsea cables, we know, are one of the most vulnerable components in offshore wind. They account for a very large proportion of insurance claims. And there are growing losses from cable and CPS failures. In 2020, for example, over £500 million claims, £500 million worth of claims. There have been some very high-profile cable protection system failures as well. Some revealed in 2021, and it turned out that that was, in fact, an industry-wide problem. So the question is there a disconnect between the design and the implementation of cables and cable protection systems? One of the issues is that cable and CPS systems are typically designed using and modeled using industry standard simulation software. And that software relies on inputs provided by engineers that can be quite difficult to determine. And that leads to a wide range of possible outputs. So you can make that design fit your requirements by adjusting the input parameters. So real-world wave forces, for example, and seabed interactions may differ significantly from the idealized models. So the answer to calibrate those models is to measure cable dynamics in situ. What can we measure in situ? Well, vibration and acceleration are the most obvious. This is an example of a monitoring system at Barrow Wind Farm in the northwest of the UK. And in this particular instance, we can see the inter-array cable coming down the J-tube to a bow mouth, and then there's a CPS system on it. And we chose to monitor at 3 points, monitoring linear accelerations on that cable. In this particular instance, that data was then cabled back to the surface and brought out to a data logger. Not only were we measuring the cable accelerations, but we were also monitoring the forcing waves and currents simultaneously and bring all of that information back into one data stream. We also manufacture a range of other instrumentation, including vortex-induced vibration data loggers and other accelerometers. And in the display that you see here on the right, this is a 6-axis display from the Robin Rig wind farm in the northeast, I beg your pardon. And that is showing both linear and rotational accelerations on 3 points on a cable protection system. It's also possible to measure strain, for example, and this particular instrument, the Kinectron, was designed for both retrofit and new build installations. You can attach it to tubulars, pipelines, risers, cables, or cable protection systems, and it measures on 3 quadrants: strain, acceleration, and non-directional waves through its pressure sensor. You can see there's strain gauges at the 12 o'clock, 3 o'clock, and 6 o'clock position that allow you to monitor not just axial strain, but also torsion and bending moment. Well, this is designed to be installed by ROV. It can also be installed by diver with the flotation installed there. Here we've got a little bit of video that shows that particular instrument being installed on a jacket offshore North Sea. And you can see it being positioned on in fact, this is a 1.2 meter diameter structural member. And there you can see it installed and then being placed into position. And this is a typical data set from that. So this is actually the vibration data. There are two structural resonant frequencies shown as lines, horizontal lines. We're looking at a 3-month timescale here. And on the y-axis, we've got frequency. So we're looking at the frequency of vibrations on this particular instrument. And right down at the bottom, the dark red there is coming from wave-induced vibrations. So we measure both vibrations and strain on this particular instrument. And what you can also see, the vertical stripes are broadband vibrations across the whole structure. Typically, this would be from drilling or other machinery. So if we combine technologies to monitor cable and cable protection systems, what are the things that we can measure? Well, primary measurements are accelerations, rotational, strain, and then derived measurements of velocity, displacement, gyros, attitude, the angle of your cable, and additional displacement monitoring techniques using acoustics, and further data, including waves and currents from your metocean data, that's what's forcing the movements, and other performance data, such as, for example, the cable temperature. But how do we get this data back? Here we come to through-water communications. It's always a challenge to get data back from underwater. And one of the questions we have to ask ourselves is, do we want that data for forensics to look at and analyze later, or do we need to make decisions based on it? How time critical is it? And that determines whether we log and record that data and retrieve it later, or whether we have something that is real time and giving us the opportunity to lead decisions. Self-contained data logging is typical for any system like this. And option one would be that you just go down there periodically and you'd retrieve it from where it's installed, bring it back to the surface and download the data. But that has a disadvantage, if you want to put it back, of disturbing the measurement. Option two is that you can go and download that data using high bandwidth communications, a way of communicating that data rapidly from the instrument back to the surface. Or is it going to be live reported? Well, one option is that you can cable it, as we saw in the first example at Barrow Wind Farm. So that data was cabled permanently back to the surface. But cables through the splash zone can be challenging. The alternative to that is through water communications using acoustics. But that also has some drawbacks. So let's first of all talk about the acoustic approach. When you need to measure a number of parameters in a given subsea area, that could be pipeline pressures, cathodic protection monitoring, metocean data, or subsea cable motion. You really would prefer not to be bringing lots of cables back to the surface, although in the case of a monopile, you do have something close by to do that. But we developed an acoustic system that simply takes measurements and transmits them out into the water for anything to listen. And you would then have a data hub on a support vessel, perhaps a patrolling ROV or AUV, or you could have that data hub on your monopile, for example. And then to get your real-time updates, you need to perhaps attach a little bit more intelligence to the data that you're logging. So as an add-on to self-contained data logging, using our acoustic system, we can bring all of the various parameters into an edge processing engine, which will determine what are the most important features of that data. So it may be that you're logging simple, slow-changing things like temperature or pressure, or perhaps faster things with statistical characteristics such as waves and currents, strains, motions, accelerations, etc. Our edge processing then outputs just the key salient data. Status, first of all, is the instrument working? Is it performing as we expect? Secondly, are all the readings within limits that we've preset? Or is there something that is drifting out of limits that might be a cause of concern? And then thirdly, for more complex data streams, we can gather statistics to transmit over a given reporting period of perhaps an hour, perhaps an 8-hour period, perhaps a whole day. And then we transmit that data, very concise through water updates, and that comes back to our data hub and is brought all together onto a custom dashboard. So here are some examples of custom dashboards showing, for example, cathodic protection or underwater hose leaks, underwater pressure manifolds, etc. But if you find that there is something of concern in your data, then you need to go back and try and extract the forensics and find out what's going on. And here we have our optical communication link, which you can activate using either a lightweight ROV or indeed a work-class ROV that maybe is doing a regular inspection. So you can send that ROV down on spec, or you can gather that data on routine inspections. And then you have a full data set to work with and analyze in detail. So in summary, you use the acoustics to gather data over longer range, but it's very small amounts of data, or you use optics to gather large amounts of data, but at close range. So if we then bring all of these measurements together and these systems together, we come up with a system that is integrating both measurement and communication. So we combine the existing technologies of vibration and acceleration monitoring and strain monitoring together with edge processing and acoustic communications. We put together an operator dashboard so that you can see the key data in near real time and then make decisions about whether you then need to go back and download more data from your instruments to find out what's going on. And this gives you the ability to have clear early warnings or peace of mind that your system is operating correctly, but also the ability to go down and find out in more detail what might be going wrong. So, in summary, the cable and cable protection system market is ripe for change. The way it is right now, each cable or CPS model is an evolution of what went before. CPS systems are designed to protect the cables for as long as possible, and that's about it. So what we're offering is smart monitoring that would massively inform not just future CPS designs, but also provide cable owners with condition-based maintenance dashboards. That information is not based on a theoretical model, but on actual data, including strains, temperatures, motion, etc., for that individual CPS or cable at that specific site. And that would result in avoiding unnecessary shutdowns, reducing unplanned outages, optimizing spares holdings according to real-time condition and forecast requirement, and enabling well-planned maintenance, reducing last-minute, high-cost interventions. And that will lead to improved CPS and cable designs, better risk management, and fewer unexpected insurance claims. Thank you.